Hi, welcome to today's class. Today we're looking at a question from gas calculation, and which also you can see under your stoichiometry reaction. Okay, but basically this is actually coming from Gay-Lussac's law. I'm sure you know what Gay-Lussac's law says. Gay-Lussac's law actually, or Gay-Lussac himself, he happened to be a contemporary of Avogadro's. Why Avogadro's based his postulation on moles or molecules, Gay-Lussac based his postulation on what we call gases. Okay, for example, Gay-Lussac's law states that when gases react, they do so in volume, which are in simple ratio to one another and to the volume of the products if gaseous provided temperature and pressures remain constant. Okay, so here, what Gay-Lussac's law is saying is that if you have, let's say, CO2 reacting with oxygen now, you have, if you have CO rather reacting with this, you have CO2. And in this case now, you balance the equation. So this is a gas, this is a gas, this is a gas. And they do so in simple ratio 2, ratio 1, ratio 2. And if you look at the volume ratio of these to the products is similar. Okay, so you can say 2 to 2. So they are in simple ratio. So looking at this question now that we are given from Gay-Lussac's law, we are asked to find the volume of the resulting gases and the gas in excess. Okay, we need to know the gas in excess. Now, to identify that, it's also important we know the limiting reagent or the limiting gas. So 50 cm cube of hydrogen reacted and sparked with 200 cm cube of air containing 21% oxygen. If all the volume were measured at STP, calculate the volume of 1, the resulting gases, and 2, gas in excess. So let's look at it quickly. The first thing is to find the converting this percent, the volume of oxygen. So we have 21% multiplied by the 100, 200. So we have 42. And since it has to do with the air, look at it here, air was mentioned, so we need to know the volume of other gases in the air. Volume of other gases in the air. The volume of other gases in the air, that's 200 minus 42. So that gives you 158 centimeter cube. So remember, in the air, we have various gases. You have your CO2. You even have some inert gases. You have nitrogen, and nitrogen happens to be the highest. So you have all of them. So the entire thing, okay? So it's what you have inside here. Okay, so the next thing is to write the equation of reaction. After you have done this, writing the equation of the reaction, the next thing is to write the equation of the reaction. So we have hydrogen, oxygen, to give you steam, that this is a steam. So we need to balance the equation. So we have 2 here. We have 2 here. So here is 2 volume. Here is 1 volume. And here is 2 volume. So this is volume of reaction. Now, what's the next thing? Please, I'd like you to follow. So from the equation of reaction, we have 2 volume. So it's like ratio 2 to 1, ratio 2. That's what we have here. That's the volume ratio here. 2, 1, 2. So what's the next thing? The next thing is for us to now begin to do some proper analysis. What's the volume of hydrogen we were given before reaction? Before it sparked, before there was a reaction, it was 50. That is volume of hydrogen before sparking or before reaction was 50. How about the volume of oxygen before sparking or before reaction is here, 42. Weren't given that of steam. So we're not given that of steam, so we have to do something about that later. Then after sparking, that is, after reaction had taken place, we now want to find out how many volume of hydrogen went into the reaction and how many volume of oxygen was needed to counterbalance the volume of hydrogen that went into the reaction. To do this, please, you have to calm down very well as I explain mathematically. As I explain. Now, you think now, as we do what we call ratio, I'm going to use ratio here. You think quickly. Here, I have 50. Now, think a while. If I say that 40 should go in this reaction out of the 50 that was provided, and you know that this is 2:1, it means that I will need something like 20 here, 40 to 20, so that by the time I divide again, I'm back to 2:1. So it means that you will have 10 SS here, you have 22 SS here, and that's not possible. You cannot have two gases being SS. One has to be limiting reagent, that is the one that is in short supply, or the one that is first used up in a system or a reaction is called the limiting reagent, and that determines the nature of the reaction. And then the SS is the one that is in excess supply, the one that is in abundance beyond the reaction required. That's what we mean SS reagent. Okay, so I might have to change again. How about if the entire 50 here went into the reaction? How many will be needed here? 25. So we say that the entire thing here went into the reaction and only 25 went in. And then if only 25 went in here, so we have SS 17 that will be left, that will not go in. How did I get 17? 42 minus 25. 17 did not go. How many will be formed? The rate of disappearance equals to the rate of appearance. So 2, 2, 2, 2. You can see the volume ratio. If here was 1, then you cannot have 50 back here. So after reaction, the steam became 50. And it is because they have volume ratio. 50 was used up and 50 here was produced from here. Okay, so we have that quickly. Now the question now says that we should find the volume of the resulting gas. How do you find resulting? Resulting gas is very simple. To find your resulting gas, it is to add, number one, the volume of the unreacted, 17. Add it to the volume of the other gases in the air, 2. And then the volume of the product that was formed, that's 3. And by the time you add everything, you would have gotten your resulting gas. So do that quickly. Adding, number one, the volume of the unreacted gas, the volume of the other gases in the air, and the volume of the product that was formed, 50. So when we add all this, let me add it here, 158 plus what do you have there now? Plus 50, that's 8, that's 0, that's 2. Then plus 17, that's 5, that's 2, that's 2. So I'm having 225. So 225 is the answer to the question 1. And then number 2 says that we should find the gas in excess. Obviously, you know that oxygen is in excess, and by how much is in excess is 17, which then is the limiting reagent. Hydrogen is the limiting reagent, while oxygen is the excess reagent. I'm sure that's very simple, so you can just look at it. In case you are confused, you can drop your question in the comment section. Bye.